From its rise to its declassification to the various things you might not have known, join me as we explore Pluto, facts and history, the reclassified dwarf planet. Number 8. The Finding of Pluto. Before one can dive into the controversy of the declassification of Pluto, one must dive into the history of the planet that started it all. And believe it or not, the finding of Pluto was due to one of its brethren, Uranus. In the 1840s, Urbain Le Verrier used Newtonian mechanics to predict the position of the then undiscovered planet Neptune, after analyzing perturbations in the orbit of Uranus, which, if you think about it, is a rather clever and unique way of finding a planet, given the technology that they had at the time, further proving that the earlier generations of astronomers were much more clever than people think. Subsequent observations of Neptune in the late 19th century led astronomers to speculate that Uranus's orbit was being disturbed by another planet besides Neptune. Thus, Percival Lowell, a wealthy Bostonian who had founded Lowell Observatory in Flagstaff, Arizona in 1894, started an extensive project in search of a possible ninth planet, which he termed Planet X. By 1909, Lowell and William H. Pickering had suggested several possible celestial coordinates for such a planet. Lowell and his observatory conducted his search until his death in 1916, but they didn't find the planet they were looking for. Ironically though, his surveys had captured two faint images of Pluto on March 19th and April 7th, 1915, but they were not recognized for what they were. Then came a long legal battle that halted the finding of Planet X. Vesto Melvin Slifer, the observatory director, gave the job of locating Planet X to 23-year-old Clyde Tombaugh, who had just arrived at the observatory. On February 18, 1930, after nearly a year of searching, Tombaugh discovered a possible moving object on photographic plates taken on January 23rd and 29th. A lesser quality photograph taken on January 21st helped confirm the movement. The reason they hadn't noticed the movement before was because of Pluto's incredibly long orbit around the Sun. More on that later. Number 7. Orbits and rotations. As noted, one of the main reasons why Pluto was not easily found in the sky was not just because of its distance from the Sun, though that certainly helped. It was because its yearly orbit was so long that it quite literally took forever from the view of Earth to see that it really was moving across the sky in an orbital pattern. The average year on Pluto is nearly 248 years long when you round it up. That's over 3 times the average lifespan of a human, which is 79 years, which is a very long time indeed. Now, as for its daily orbit, that's much faster, but it is still relatively slow compared to the Earth. A day on Earth is 24 hours roughly, but on Pluto, it's 153 hours. Trying to get a cycle of life on there would be a very hard thing indeed. But the reasons for these orbits and rotations isn't just because of its makeup, but its distance from the Sun. The farther you are from an object's gravity, the less pull it has on you. That's why if you look at the orbits of the planets from Mercury to Neptune, you'll see that it gets longer and longer because its pull is lesser. Number 6. Named by a girl. No, we're not joking with you here. Pluto is the only world so far named by an 11-year-old girl. In 1930, Venetia Burney of Oxford, England, suggested to her grandfather that the new discovery be named for the Roman god of the underworld. He forwarded the name to the Lowell Observatory and it was selected, though it should be noted that there were other names suggested. But by the time they got to the final few, Pluto made the most sense and thus got all the votes. That means that an 11-year-old girl outthought various astronomers and accomplished people in naming a planet. Continuing on with the mythology, Pluto's moons are named for other mythological figures associated with the underworld. Charon is named for the river Styx boatman who ferries souls in the underworld. Nyx is named for the mother of Charon, who is also the goddess of darkness and night. Hydra is named for the 9-headed serpent that lived in a place that was an entrance to the underworld. Kerberos is named after the 3-headed dog of Greek mythology, who also guarded the gate to the underworld at times. And Styx is named for the mythological river that separates the world of the living from the realm of the dead. Pluto's place in mythology is thus: Pluto is the name of the Roman god of the underworld, equivalent to the Greek Hades. However, the Greek name Pluton, from which the Romans derived their name Pluto, was also occasionally used as an alternative name for Hades, but Pluto is definitely the Roman spelling, which is somewhat poignant when you think about Pluto, the planet, as a whole, because if you think about its placement in the solar system, you'll note that it's not exactly one that is close to its brethren. It's the farthest away, which is relevant because the underworld, where Pluto, Hades, lives, is incredibly far away from the heaven of their mythologies in Olympus. So it's honestly rather perfect that the farthest planet from the bright sun would be named after the underworld where everything goes to die. Number 5. Atmosphere. Pluto has a tenuous atmosphere consisting of nitrogen, N2, methane, CH4, and carbon monoxide, CO, which are in equilibrium with their ices on Pluto's surface. According to the measurements by New Horizons, the surface pressure is about 1 Pascal, 10 microbars, roughly 1,000,000 to 100,000 times less than Earth's atmospheric pressure. It was initially thought that as Pluto moves away from the Sun, its atmosphere should gradually freeze onto the surface. Studies from data and ground-based occultations show that Pluto's atmospheric density increases, and that it likely remains gaseous throughout Pluto's orbit. New Horizons observations show that atmospheric escape of nitrogen to be 10,000 times less than expected. Alan Stern has contended that even a small increase in Pluto's surface temperature can lead to exponential increases in Pluto's atmospheric density, from 18 hectopascal to as much as 280 hectopascal, 3 times that of Mars to a quarter that of the Earth. At such densities, nitrogen could flow across the surface as liquid, just like sweat cools the body as it evaporates from the skin. The sublimation of Pluto's atmosphere cools its surface. The presence of atmospheric gases was traced up to 1,670 kilometers high. The atmosphere does not have a sharp upper boundary like other planets in the solar system. The presence of methane, a powerful greenhouse gas in Pluto's atmosphere, creates a temperature inversion, with the average temperature of its atmosphere tens of degrees warmer than its surface. Though observations by New Horizons have revealed Pluto's upper atmosphere to be far colder than expected, 70 degrees Kelvin as opposed to about 100 degrees Kelvin. Pluto's atmosphere is divided into roughly 20 regularly spaced haze layers up to 150 kilometers high, thought to be the result of pressure waves created by airflow across Pluto's mountains. Number 4. Declassification. So as noted, in 1930, Pluto became a full-on planet. But 76 years later, in 2006, things changed, and the planet was later labeled as a dwarf planet. But how did it come to be labeled that after 70-plus years of it being labeled as a planet? The answer is a little more complicated than you might expect. Around the year 1992, many bodies were discovered orbiting in the same volume as Pluto, showing that Pluto is part of a population of objects called the Kuiper Belt. This made its official status as a planet controversial, with many questioning whether Pluto should be considered together with or separately from its surrounding population. On July 29, 2005, astronomers at Caltech announced the discovery of a new trans-Neptunian object, Eris, which was substantially more massive than Pluto, and the most massive object discovered in the solar system since Triton in 1846. Its discoverers and the press initially called it the 10th planet, although there was no official consensus at the time on whether to call it a planet. And obviously, based on what happened next, our solar system never grew to 10 planets full. Everything changed, though, in 2006 when the International Astronomical Union, IAU, decided that after many decades of debates, they needed to figure out a concrete way of defining what a planet was, no matter the consequences and backlash that it may cause from the community at large. Thus, they made 3 defining traits for what a planet must be in order to be a true planet. Here are the 3 defining traits. Number 1. The object must be in orbit around the Sun. Number 2. The object must be massive enough to be rounded by its own gravity. More specifically, its own gravity should pull it into a shape defined by hydrostatic equilibrium. Number 3. It must have cleared the neighborhood around its orbit. It may on the surface seem like Pluto clearly meets all the requirements, but it doesn't. Pluto fails to meet the third condition. Its mass is substantially less than the combined mass of the other objects in its orbit, 0.07 times, in contrast to Earth, which is 1.7 million times the remaining mass in its orbit, excluding the Moon. Since Pluto and others like it do not meet the full classifications of the new traits rules of the IAU, they officially made the classification of dwarf planet, meaning one that is smaller than the rest of the planets and don't meet all the qualifications to be labeled as such. Number 3. Pop culture. When Pluto was reclassified in 2006 from a planet to a dwarf planet, there was widespread outrage on behalf of the demoted planet. As the textbooks were updated, the internet spawned memes with Pluto going through a range of emotions, from anger to loneliness. But since the release of New Horizons, images showing a very prominent heart-shaped feature on the surface, the sad Pluto meme has given way to a very content, loving Pluto that would like to once again be visited by a spacecraft. The Disney cartoon character Pluto, Mickey's faithful dog, made his debut in 1930, the same year Tombaugh discovered the dwarf planet. There is speculation that Walt Disney named the animated dog after the recently discovered planet to capitalize on its popularity, but other accounts are less certain of a direct link. Pluto has been relevant in various sci-fi TV shows and films in one way or another. There was a key character in the anime Sailor Moon, and for those who love the film Spaceballs, there was this joke. We were lost. None of us knew where we were. Then Harry starts feeling around on all the trees and he says, "I got it. We're on Pluto." I say, "Harry, how can you tell?" And he says, "From the bark, you dummies, from the bark." Finally, in the classic series The Magic School Bus, Miss Fizzle took her class across the solar system, and Arnold's cousin Janet, who was the guest on the trip, tried to collect things from each planet. When they landed on Pluto, Arnold had had enough and demanded she leave everything behind. When she refused, he took off his helmet and his head froze over. Stricken with fear, she grabbed Arnold, got everyone on the bus, and raced home to save his life. Number 2. Colony on Pluto? Despite it not being a planet anymore, there are those who think that it might be wise to have a colony or an outpost somewhere on Pluto in the future, for a very basic reason. Regardless of whether it is a planet or not, it's on the outer fringes of the solar system and thus could be used in many ways to help expand both our reach and our knowledge of the area. Now, like Mars, it would need to be a colony that would be able to provide not just sanctuary to those living in it, but have constant supplies sent to it, which obviously would be tricky. But either a scientific outpost to study the back half of the solar system, or as a waypoint station to send us into the reaches beyond our own system, having something on Pluto wouldn't be the worst idea in the world. Number 1. Will Pluto be named a true planet again? This may seem like an odd question, but it's honestly one that needs to be asked, as many, beyond people in classrooms, have challenged whether Pluto should be kept as a dwarf planet and reinstated as a regular one. Alan Stern, principal investigator with NASA's New Horizons mission to Pluto, derided the IAU resolution, stating that the definition stinks for technical reasons. Stern contended that, by the terms of the new definition, Earth, Mars, Jupiter, and Neptune, all of which share their orbits with asteroids, would be excluded. He argued that all big spherical moons, including the Moon, should likewise be considered planets. He also stated that because less than 5% of astronomers voted for it, the decision was not representative of the entire astronomical community. Even certain states petitioned the decision. California tried to label it as a heresy. New Mexico and Illinois have gone on to make laws and decrees saying that Pluto is a planet in their minds, and more have rejected that it was ever a dwarf planet. So while it may be a dwarf planet now, that doesn't mean that it'll be one forever. From its status in the solar system to some of the unique things about it and more, join me as I show you Ceres, Facts and History, the mysterious dwarf planet. Number 10. What is Ceres? Dwarf planet Ceres is the largest object in the asteroid belt between Mars and Jupiter, and the only dwarf planet located in the inner solar system. It was the first member of the asteroid belt to be discovered when Giuseppe Piazzi spotted it in 1801. And when Darwin arrived in 2015, it became the first dwarf planet to receive a visit from a spacecraft. Called an asteroid for many years, Ceres is so much bigger and so different from its rocky neighbors that scientists classified it as a dwarf planet in 2006. Even though Ceres comprises 25% of the asteroid belt's total mass, tiny Pluto is still 14 times more massive. If you wanted to compare it to the Earth, think of it like this. If the Earth was a nickel, Ceres would be a poppy seed in comparison. Number 9. The history and discovery of Ceres. The finding of Ceres is a bit more in-depth than we teased in the last entry, so here's a bit of a deeper look at its finding. Johann Elert Bode first suggested that an undiscovered planet could exist between the orbits of Mars and Jupiter in 1772. Kepler had already noticed the gap between Mars and Jupiter in 1596. Bode observed that there was a regular pattern in the size of the orbits of known planets, and that the pattern was marred only by the large gap between Mars and Jupiter. A curious finding indeed. The pattern predicted that the missing planet ought to have an orbit with a radius near 2.8 astronomical units, AU. William Herschel's discovery of Uranus in 1781, near the predicted distance for the next body beyond Saturn, increased the beliefs of Bode. And in 1800, a group headed by Franz Xaver von Zach, editor of the Monatliche Correspondence, sent requests to 24 experienced astronomers, whom he dubbed the Celestial Police, asking that they combine their efforts and begin a methodical search for the expected planet. Although they did not discover Ceres, they later found several large asteroids. But this wasn't the end, this was just the beginning. One of the astronomers selected for the search was Giuseppe Piazzi, a Catholic priest at the Academy of Palermo, Sicily. Before receiving his invitation to join the group, Piazzi discovered Ceres in January 1801, though he didn't know it at the time. Rather, he thought it was a comet and apparently found Ceres 24 times. Eventually, he sent his findings to his colleagues, and by the end of 1801, they had tracked down Ceres and was able to further document its movements. But was it a dwarf planet right then and there? Nope. Number 8. Classification issues. Something you must remember is that when it came to early astronomy is that the universe as a whole was still unknown in the grand scale, and various notions about were changing and evolving with each century and new discovery. The categorization of Ceres has changed more than once and has been the subject of some disagreement over the years and decades since its finding. Johann Elert Bode believed Ceres to be the missing planet. He had proposed to exist between Mars and Jupiter, at a distance of 419 million kilometers, 2.8 AU from the Sun. Ceres was assigned a planetary symbol and remained listed as a planet in astronomy books and tables, along with 2 Pallas, 3 Juno, and 4 Vesta for half a century. As other objects were discovered in the neighborhood of Ceres, it was realized that Ceres represented the first of a new class of objects. In 1802, with the discovery of 2 Pallas, William Herschel coined the term asteroid, star-like, for these bodies, writing that they resemble small stars so much as hardly to be distinguished from them, even by very good telescopes. As the first such body to be discovered, Ceres was given the designation 1 Ceres under the modern system of minor planet designations. By the 1860s, the existence of a fundamental difference between asteroids such as Ceres and the major planets was widely accepted, though a precise definition of planet was never formulated, at the time anyway. So what changed? Pluto, that's what. If you recall, for a long time Pluto was the 9th planet of the solar system, and still is in the minds of many. But in 2006, a massive debate waged between scientists and astronomers as to whether Pluto was a planet or something else. This, of course, brought up Ceres, who at one time was considered a planet before the change to asteroid classification. After a long debate and some somewhat arbitrary definitions of planet, both Pluto and Ceres were labeled dwarf planets by the committee in charge, though some still think of Ceres as an asteroid. Number 7. Structure and surface. Ceres is more similar to the terrestrial planets, Mercury, Venus, Earth, and Mars, than its asteroid neighbors, but is much less dense. One of the similarities is a layered interior, but Ceres' layers aren't as clearly defined. It probably has a solid core and a mantle made of water ice. In fact, Ceres could be composed of as much as 25% water. If that is correct, Ceres has more water than Earth does. Ceres' crust is rocky and dusty with large salt deposits. The salts on Ceres aren't like table salt, sodium chloride, but instead are made of different minerals like magnesium sulfate. As for the surface, it is covered in countless small young craters, but none are larger than 175 miles, 280 kilometers in diameter. This is surprising given that the dwarf planet must have been hit by numerous large asteroids during its 4.5 billion year lifetime. The lack of craters might be due to layers of ice just below the surface. The surface features could smooth out over time if ice or another lower density material, such as salt, is just below the surface. It's also possible that past hydrothermal activity such as ice volcanoes erased some large craters. Within some of Ceres' craters, there are regions that are always in shadow. It's possible that without direct sunlight, these cold traps could have water ice in them for long periods of time. Number 6. Orbits, rotations, and seasons. Ceres takes 1,682 Earth days, or 4.6 Earth years, to make one trip around the Sun. As Ceres orbits the Sun, it completes one rotation every 9 hours, making its day length one of the shortest in the solar system. It's not the shortest. That would be another dwarf planet near Neptune called Haumea, but still that's a day that's basically 1/3 of what we have here on Earth. Ceres' axis of rotation is tilted just 4 degrees with respect to the plane of its orbit around the Sun. That means it spins nearly perfectly upright and doesn't experience seasons like other more tilted planets do, which, combined with the lack of an atmosphere, as far as scientists can tell, means that it's not the most habitable of planets, regular or dwarf, out there. But it still holds a big place in our culture, believe it or not. Number 5. Pop culture. The largest body in the asteroid belt, Ceres has amassed a number of references in science fiction stories of the 20th and 21st centuries. In the TV series The Expanse, Ceres is inhabited by humans, and in the PC game Descent, one of the secret levels takes place on Ceres. In the video game Destiny, Ceres was colonized by an alien race called the Fallen at the end of humanity's golden age. Ceres was later destroyed by a civilization of post-humans who inhabit the asteroid belt. Believe it or not though, Ceres has ties to something that many of you consume every single day. Ceres is named for the Roman goddess of corn and harvests. The word cereal comes from the same name. Number 4. Formation. Ceres formed along with the rest of the solar system about 4.5 billion years ago, when gravity pulled swirling gas and dust in to become a small dwarf planet. Scientists describe Ceres as an embryonic planet, which means it started to form but didn't quite finish. Nearby Jupiter's strong gravity prevented it from becoming a fully formed planet. About 4 billion years ago, Ceres settled into its current location among the leftover pieces of planetary formation in the asteroid belt between Mars and Jupiter. It almost makes you wonder what could have been if Jupiter had been just a little bit farther away, or a bit smaller in size, and thus wouldn't have exerted its gravity on Ceres. What kind of planet would it have been if it was fully grown? Would it have been our 5th planet instead of Jupiter? We'll never know, but the questions are intriguing. Number 3. Exploration. Despite us knowing a lot about Ceres, the fact of the matter is that pretty much everything we found out about the dwarf planet has been made at ground level. Not for lack of trying to get there with something else, mind you. In 1981, a proposal for an asteroid mission was submitted to the European Space Agency, ESA, named the Asteroidal Gravity Optical and Radar Analysis, AGORA. This spacecraft was to launch sometime in 1990 to 1994 and perform 2 flybys of large asteroids. The preferred target for this mission was Vesta. AGORA would reach the asteroid belt either by a gravitational slingshot trajectory past Mars or by means of a small ion engine. However, the proposal was refused by the ESA. Future projects were proposed by or drawn up for NASA, the ESA, and even the Soviet Union, but none have been approved or taken place in anything outside of concept. Number 2. Potential for life? Ceres is one of the few places in our solar system where scientists would like to search for possible signs of life. It has something a lot of other planets don't: water. Here on Earth, water is essential for life, So it's possible that with this ingredient and a few other conditions met, life could maybe exist there. Living things on Ceres, if they are there at all, would likely be very small microbes similar to bacteria. And while Ceres may not have living things today, there could be signs it harbored life in the past. If the solar system has shown us anything in the recent past, it's that we don't know as much as we think we do about certain things in our solar system. So even if there's only a slim chance that there could be the possibility of life on Ceres, big or small, it's worth checking out. Now granted, getting to Ceres right now isn't the easiest of things, but if we were able to breach that gap and study it, that could be potentially life-changing. Now sure, we're speculating a lot here because we don't know if there is or isn't life on Ceres, but there could be. And isn't that enough of a reason to at least go and try to find life on it? Seems logical to us, but why stop there? What if we could do more? Number 1. Living on Ceres? As you all know, or at least hopefully know, our goal for this current decade is to go and reach Mars. Then we will start to build a colony there and potentially start expanding across the solar system. What does this have to do with Ceres? Simple. Where is it located? In the asteroid belt between Mars and Jupiter, right? Well, when it comes to space travel, everyone thinks that we need to just shoot for the end goal. But that's not true, or at least not in certain circumstances. We're aiming for Mars because of various factors, including it's our neighbor, it has water, and we feel that we can live there, as well as the fact that it is a gateway to the back half of the solar system. But just trying to jump from Mars to Jupiter could be fraught with problems. So what if we had a stop in between? Yeah, what if Ceres could become like a waypoint station for us to use to help ensure that we got to Jupiter and beyond? It may sound like more work, but given the state of our technology right now and how we're handling things on the spacefront front, especially with the recent success of the SpaceX launch with astronauts, having a buffer zone and an extra place to stop, if you will, could be huge. And many are already thinking of putting similar stations on moons like Titan, Europa, and maybe more. It would help open things up, and that would be a godsend for future missions. Plus, as time goes on, we could send out multiple ships to multiple parts of the solar system based on where the dwarf planet is in its rotation, which would be a good place to launch probes and satellites as well to further explore things. Which of course brings us to the asteroid belt that Ceres resides in. If we have a station there, we could further explore the belt, and potentially even mine the belt for resources. It may seem like a far-fetched idea at present, but when you look deeper into what Ceres means and what it could be, it doesn't seem like such a long shot. From its fast-spinning rotation to the fact that it looks like a football and more. Join me as I detail for you Haumea facts in history, the fast-spinning dwarf planet. Number 8. What is Haumea? Despite our solar system being one that is very much in-depth in terms of public knowledge about what's out there are a few things that don't exactly make the headlines, and Haumea is one of them. Why is that? Because it's a dwarf planet. A dwarf planet is one that has the shape of a planet in part or in whole, and has the size to match up to one in part, but it's just a bit smaller and has other issues and thus doesn't meet the qualifications of a true planet. Haumea is found in the Kuiper Belt that is just beyond the planet Neptune. Two teams claim credit for its discovery. Mike Brown and his team at Caltech discovered Haumea December 28, 2004, on images they had taken on May 6, 2004. On July 20, 2005, they published an online abstract of a report intended to announce the discovery at a conference in September 2005. At around this time, Jose Luis Ortiz Moreno and his team at the Instituto de Astrofísica de Andalucía at Sierra Nevada Observatory in Spain found Haumea on images taken on March 7th to 10th, 2003. Ortiz emailed the Minor Planets Center with their discovery on the night of July 27, 2005. Brown initially conceded discovery credit to Ortiz, but came to suspect the Spanish team of fraud upon learning that his observation logs were accessed from the Spanish observatory the day before the discovery announcement. These logs included enough information to allow the Ortiz team to pre-cover Haumea in their 2003 images. and they were accessed again just before Ortiz scheduled telescope time to obtain confirmation images for a second announcement to the MPC on July 29th. Ortiz later admitted he had accessed the Caltech observation logs, but denied any wrongdoing, stating he was merely verifying whether they had discovered a new object. Pre-covery images of Haumea have been identified back to March 22, 1955. IAU protocol is that discovery credit for a minor planet goes to whoever first submits a report to the MPC, Minor Planet Center, with enough positional data for decent determination of its orbit, and that the credited discoverer has priority in choosing a name. However, the IAU announcement on September 17, 2008, that Haumea had been named by dual committee established for bodies expected to be dwarf planets did not mention a discoverer. The location of discovery was listed as the Sierra Nevada Observatory of the Spanish team, but the chosen name Haumea was the Caltech proposal. Ortiz's team had proposed Addisina, the ancient Iberian goddess of spring, which as a chthonic deity would have been more appropriate for a Plutino. It's ironic to find teams of people vying for the rights of discovery, but that is indeed what happened here, and because of that, Haumea has a bit more of a controversial history than other true planets in the solar system. Number 7. Size and distance. With a radius of about 385 miles, 620 kilometers, Haumea is about 1/14 the radius of Earth. If Earth were the size of a nickel, Haumea would be about as big as a sesame seed. This is one of the reasons why it's called a dwarf planet, because while it has an impressive size, it doesn't measure up to the other planets of the solar system. The irony of this is manifold, not the least of which is that there have been several updates to the size and radius and dimensions of Haumea as a whole. While no one doubts its elongated shape, which we'll be touching on in a sec, the dimensions on all its sides have been conflicting depending on who you talked with, including 2017 and 2019 studies trying to figure out what the true dimensions are. From an average distance of 4,010 million miles, 6,452 million kilometers, Haumea is 43 astronomical units away from the Sun. One astronomical unit, abbreviated as AU, is the distance from the Sun to Earth. From this distance, it takes sunlight 6 hours to travel from the Sun to Haumea. This is rather long compared to the Earth, where it takes mere minutes to reach us. That's why it's much colder in the solar system the farther that you go out into the distance. Number 6. Orbits and rotations. Haumea is a bit curious when it comes to its orbits and rotations. It takes 285 Earth years to make one trip around the Sun. However, as Haumea orbits the Sun, it completes one rotation every 4 hours, making it one of the fastest rotating large objects in our solar system. Think about that for a second. This object has a day in about 1/6 the time the Earth does. So that would mean if you did an 8-hour shift at work, Haumea has already clocked 2 days in the record books. That's incredibly fast, which is why many study it, because that's an impressive amount of speed to go that fast in place. It is possible a massive impact billions of years ago set off Haumea's spin and created its moons, but more on those later. The other thing to note here is that the rotation of a planet can affect its shape, and because Haumea is spinning so fast, its shape is quite literally elongated. So if you were to look at it from its side in the length version, you would say that it doesn't look like a true planet, it looks like a football, which is most definitely a shape that not many people associated with a planet, and yet it happens more than you think in the grand scale of the universe. It just depends on the forces put upon it, including its own rotation and the gravity of the Sun exerted on it. Number 5. Moons. The fact that Haumea has moons is a bit ironic, mainly because there are planets like Mercury and Venus that don't have moons at all, and they are full planets, while a dwarf planet like Haumea has 2. The 2 in question were discovered around Haumea through observations using the WM Keck Observatory by a Caltech team in 2005. The outer and larger of the two satellites was discovered in January 2005 and formally designated S/2005 2003 EL611, though nicknamed Rudolph by the Caltech team. The smaller inner satellite of Haumea was discovered during June of 2005, formerly termed S/2005 2003 EL612 and nicknamed Blitzen. Get it? They're named after reindeer. On September 7, 2006, both satellites were numbered and admitted into the official Minor Planet Catalog as 136108, 2003 EL611 and 2 respectively. Eventually, though, they got more appropriate names in 2008 via Hiaka and Namaka. Each moon was named after a daughter of Haumea, the Hawaiian goddess of fertility and childbirth. Hiaka is the goddess of dance and patroness of the Big Island of Hawaii, where the Mauna Kea Observatory is located. Namaka is the goddess of water and the sea. She cooled her sister Pele's lava as it flowed into the sea, turning it into new land. In her legend, Haumea's many children came from different parts of her body. The dwarf planet appears to be almost entirely made of rock, with only a superficial layer of ice. Most of the original icy mantle is thought to have been blasted off by the impact that spun Haumea into its current high speed of rotation, where the material formed into the small Kuiper Belt objects in Haumea's collisional family. There could therefore be additional outer moons smaller than Namaka that have not yet been detected. It'll be up to other astronomers to go and see where they are if they do indeed exist. Number 4. The surface of Haumea. In 2005, the Gemini and Keck telescopes obtained spectra of Haumea, which showed strong crystalline water ice features similar to the surface of Pluto's moon Charon. This is peculiar because crystalline ice forms at temperatures above 110 Kelvin, whereas Haumea's surface temperature is below 50 Kelvin, a temperature at which amorphous ice is formed. In addition, the structure of crystalline ice is unstable under the constant rain of cosmic rays and energetic particles from the sun that strike objects like these. The timescale for the crystalline ice to revert to amorphous ice under this bombardment is on the order of 10 million years. Yet trans-Neptunian objects have been in their present cold temperature locations for timescales of billions of years. Radiation damage should also redden and darken the surface of trans-Neptunian objects, where the common surface materials of organic ices and tholin-like compounds are present, as is the case with Pluto. Therefore, the spectra and colors suggest Haumea and its family members have undergone recent resurfacing that produced fresh ice. However, no plausible resurfacing mechanism has been suggested, making its surface one of the biggest mysteries of the dwarf planet, and further proof that more study is needed on it and about it. Haumea is as bright as snow, with an albedo or reflectivity amount in the range of 0.6 to 0.8, consistent with crystalline ice. Other large objects like Haumea, such as Eris, appear to have albedos as high or higher. Best fit modeling of the surface spectra suggested that 66% to 80% of the Haumean surface appears to be pure crystalline water ice, with one contributor to the high albedo possibly hydrogen cyanide or phyllosilicate clays. Inorganic cyanide salts such as copper potassium cyanide may also be present. However, further studies of the visible and near-infrared spectra suggest a homogeneous surface covered by an intimate one-to-one mixture of amorphous and crystalline ice, together with no more than 8% organics. The absence of ammonia hydrate excludes cryovolcanism, and the observations confirm that the collisional event must have happened more than 100 million years ago, in agreement with the dynamic studies. The absence of measurable methane in the spectra of Haumea is consistent with a warm collisional history that would have removed such volatiles. This means that more research is required to figure out just how this surface came to be how it is, and answers could potentially highlight other properties of not just this dwarf planet, but other entities in the Kuiper Belt. Number 3. Formation. Haumea is a member of a group of objects that orbit in a disk-like zone beyond the orbit of Neptune called the Kuiper Belt. This distant realm is populated with thousands of miniature icy worlds which formed early in the history of our solar system about 4.5 billion years ago. These icy rocky bodies are called Kuiper Belt objects, trans-Neptunian objects, or Plutoids. As for how Haumea itself was formed and how it could get its shape and rotation is a bit up for debate, mainly because given the nature of the Kuiper Belt and how there are numerous objects of various size within it, there are many ways it could have formed. Many feel that it was a collision event within the belt that set it apart, as well as giving it the 2 moons that we talked about earlier. It's also possible that it was lumped together like many other rocks and asteroids, and even planets in our solar system. There is no true way of knowing. Though given the constantly evolving picture of our universe and how it was formed, there is potential that there are even more options to what really happened. And should they be discovered, it could reveal more not just about Haumea, but the formation of the Kuiper Belt as well. Number 2. The Ring. A discovery in 2017 indicated the presence of a ring around this dwarf planet. This represents the first ring system discovered for an object like Haumea. This ring has a radius of about 2,287 kilometers, a width of approximately 70 kilometers, and an opacity of 0.5. It is well within Haumea's Roche limit, which would be at a radius of about 4,400 kilometers if it were spherical. Being non-spherical pushes the limit out farther. The ring plane approximately coincides with Haumea's equatorial plane and the orbital plane of its larger outer moon, Hiaka. The ring is also close to the 3-to-1 resonance with Haumea's rotation. The ring is estimated to contribute 5% to the total brightness of Haumea. In a study about the dynamics of ring particles published in 2019, Othon Cabo Winter and colleagues have shown that the 1-to-3 resonance with Haumea's rotation is dynamically unstable, but that there is a stable region in the phase space consistent with the location of Haumea's ring. This indicates that the ring particles originate on circular, periodic orbits that are close to, but not inside the resonance. This is a fascinating find because you wouldn't expect an object like Haumea to have a ring, and it's fair to say that many never thought a dwarf planet like this could have a ring, but indeed it does, and that opens up many possibilities. Number 1. Future discoveries of Haumea. If not obvious, Haumea is still somewhat of a mystery to astronomers in terms of its attributes, its history, and everything that it represents. In many ways, it should not exist like it does, and yet it does, and it raises many interesting questions about what else is in the Kuiper Belt, and what it could mean for our solar system as a whole. No doubt some would like to land on the dwarf planet to get a closer look, but that's unlikely at the present time. So until that point, we'll just keep looking at the dwarf planet and keep trying to determine more about it. From its interesting name to its composition, discovery, and more, join me as we explore Makemake, facts, and history. Number 9. What is Makemake? Given the rather odd name for the object, you'd be forgiven for not knowing exactly what this entity is on its title alone. It's a dwarf planet, and possibly one of the biggest in our solar system. Along with fellow dwarf planets Pluto, Eris, and Haumea, it is located in the Kuiper Belt, a region outside the orbit of Neptune. Slightly smaller than Pluto, Makemake is the second brightest object in the Kuiper Belt as seen from Earth, while Pluto is the brightest. This particular dwarf planet holds an important place in the history of solar system studies because it, along with Eris, was one of the objects whose discovery prompted the International Astronomical Union to reconsider the definition of a planet and to create the new group of dwarf planets, of which Pluto would be demoted from a full planet to a dwarf planet, leaving many to wonder what would have happened if this particular set of objects were never discovered at all. Would Pluto still be a planet today? The dwarf planet was named after the Rapa Nui god of fertility. If you don't know, these are the people who lived on Easter Island. Number 8. The discovery. Makemake was discovered on March 31, 2005 by a team at the Palomar Observatory led by Michael E. Brown and was announced to the public in July of 2005. The team had planned to delay announcing their discoveries of it and Eris until further observations and calculations were complete, but announced them both on July 29th when the discovery of another large object they had been tracking, Haumea, was controversially announced on July 27th by a different team in Spain. There was a bit of a fight over this, but that's another story entirely. Despite its relative brightness, it is about a fifth as bright as Pluto. Makemake was not discovered until after many much fainter Kuiper Belt objects, which no doubt struck the team finding it as odd among other things. Most searches for minor planets are conducted relatively close to the ecliptic, the region of the sky that the Sun, Moon, and planets appear to lie in as seen from Earth, due to the greater likelihood of finding objects there. It probably escaped detection during the earlier surveys due to its relatively high orbital inclination, and the fact that it was at its farthest distance from the ecliptic at the time of its discovery, in the northern constellation of Coma Berenices. Besides Pluto, Makemake is the only other dwarf planet that was bright enough that Clyde Tombaugh could have detected during his search for trans-Neptunian planets around 1930. At the time of Tombaugh's survey, it was only a few degrees from the ecliptic, near the border of Taurus and Auriga, at an apparent magnitude of 16.0. This position, however, was also very near the Milky Way, and the dwarf planet would have been almost impossible to find against the dense background of stars. Tombaugh continued searching for some years after the discovery of Pluto, but he did not find Makemake or any other trans-Neptunian objects, which is now very ironic due to all the various objects we found in that area since Pluto, going to show that while the early astronomers were incredibly talented, they did have their limits based on the technology that they wielded. Number 7. Orbit. As of April 2019, Makemake is 52.5 AU from the Sun, almost as far from the Sun as it ever reaches on its orbit. The dwarf planet follows an orbit very similar to that of Haumea, highly inclined at 29 degrees and a moderate eccentricity of about 0.16. But still, its orbit is slightly farther from the Sun in terms of both the semi-major axis and perihelion. Its orbital period is 305 years approximately, more than Pluto's 248 years and Haumea's 285 years. Both it and Haumea are currently far from the ecliptic at an angular distance of almost 29 degrees. However, it is approaching its 2033 aphelion, whereas Haumea passed its aphelion in early 1992. To put its orbit into context, a human life averages around 70 to 80 years, but there have been many who have reached 100 or over, so for it to go around the Sun once via its orbit is like those people living 3 lifetimes, which would be quite a feat indeed. Number 6. Atmosphere. Determining a planet's or dwarf planet's atmosphere is a bit tricky to do depending on its distance. This is why the search for Earth-like planets takes time, because though we can find a planet, it can take time to truly dissect the ins and outs of the atmosphere based on pictures and certain readings. In terms of Makemake, though, there was a sequence of events that allowed scientists to observe its potential atmosphere. Starlight, of all things, gave astronomers the best look yet at the dwarf planet, and it appears to be missing its atmosphere according to their findings. Although this icy world currently lacks an atmosphere, there is still a chance it could form one like a comet when it approaches the point in its orbit that is closest to the Sun, scientists added. Though obviously that would be something that would have to be looked at via various technology when the time comes to make sure that it does indeed happen. Though this isn't a definitive thing, the team who made this discovery were thrilled that they were able to make any confirmation at all. For me, it is extremely remarkable that we can get an accurate knowledge of important properties of these mysterious dwarf planets, even though they are so far away from the Earth, said lead study author Jose Ortiz, a planetary scientist at the Institute of Astrophysics of Andalusia in Granada, Spain. Only 3 years ago, we had never observed a single occultation by a trans-Neptunian object, and now we've managed to observe 12 such events, 9 of them by our international team. Getting back to the atmosphere, at most Makemake's atmosphere is 80 million to 250 million times thinner than Earth's at sea level, the researchers calculate. Still, there might be patches of atmosphere overlying warmer regions on its surface, such as dark patches that absorb more sunlight. We suspect that these dark patches might be concentrated near the latitude of the subpolar point of the planet. The subpolar point is the point of the planet where the solar rays reach the surface perpendicularly and therefore cause the maximum heating possible, Ortiz said. These dark patches might form sort of a dark band in the planet. You might wonder why such a thing is a need-to-know aspect of the dwarf planet, but think about it in the large scale. First and foremost, whether a dwarf planet has an atmosphere or not depends on various factors. So for this one to appear to either not have one or have an incredibly thin one is worth the research itself. Plus, if it does act like a comet and gain an atmosphere when it gets closer to the sun, that is an event that will wield much information. Every aspect of a planet or dwarf planet is important, especially if it is revealed that it could be viable for a human colony of some kind, or any kind, in the future. Number 5. Surface. Spectral analysis of Makemake's surface revealed that methane must be present in the form of large grains, at least 1 centimeter in size. In addition to methane, large amounts of ethane and tholins, as well as smaller amounts of ethylene, acetylene, and high-mass alkalines like propane may be present, most likely created by photolysis of methane by solar radiation. The tholins are probably responsible for the red color of the visible spectrum. Although evidence exists for the presence of nitrogen ice on its surface, at least mixed with other ices, there is nowhere near the same level of nitrogen as on Pluto and Triton, where it composes more than 98% of the crust. The relative lack of nitrogen ice suggests that its supply of nitrogen has somehow been depleted over the age of the solar system. Although the majority of it is covered by nitrogen and methane ices, where the albedo ranges from 78 to 90%. There are small patches of dark terrain whose albedo is only 2 to 12%, and that make up 3 to 7% of the surface. There has been much debate as to what these dark terrain spots are, including being shadows or something more unique. They show some degree of variation in the spectral slope, which would be associated with different abundance of the complex organic materials, byproduct of the irradiation of the ices present on the surface. However, the relative ratio of the two dominant icy species, methane and nitrogen, remains quite stable on the surface, revealing a low degree of inhomogeneity in the ice component. These results have been recently confirmed when the Telescopio Nazionale Galileo acquired new visible and near-infrared spectra for Makemake between 2006 and 2013 that covered nearly 80% of its surface. This study found that the variation in the spectra were negligible, suggesting that Makemake's surface may indeed be homogeneous. Number 4. Its name. As you likely know, the names of planets, dwarf planets, and moons in our solar system are at most times named after gods and deities across various pantheons. So it might seem odd that this one looks like it's called Makemake when in fact it's not. Before its true name was given, the Discovery team used the codename Easter Bunny for the object, because of its discovery shortly after Easter. How poetic. In July of 2008, in accordance with the IAU rules for classical Kuiper Belt objects, the dwarf planet was given the name of a creator deity, the name of Makemake, the creator of humanity and god of fertility in the myths of the Rapa Nui. The native people of Easter Island, was chosen in part to preserve the object's connection with Easter. So you see, its name was not random, it's just from a pantheon you likely don't know by heart, like with the Greek and Roman gods that the other planets and dwarf planets and moons are mostly named after. Number 3. Moon. Makemake has one provisional moon, S/2015-1, and nicknamed MK2. It is more than 1,300 times fainter than the dwarf planet. MK2 was seen approximately 13,000 miles from the dwarf planet, and its radius is estimated to be about 50 miles or 80 kilometers. The Hubble Discovery images suggest that MK2 is as dark as charcoal, which seems surprising given that Makemake is so bright. One possible explanation is that the moon's gravity is too weak to hold on to reflective ices, which sublimate off MK2's surface into space, researchers said. MK2 was spotted in observations made by Hubble's Wide Field Camera 3 in April 2015, after several previous Makemake observation campaigns had failed to turn up any satellites. Our preliminary estimates show that the moon's orbit seems to be edge-on, and that means that often when you look at the pattern, you are going to miss the moon because it gets lost in the bright glare of Makemake. Alex Parker of the Southwest Research Institute, SWRI, in Boulder, Colorado, who led the image analysis for the Hubble observations, said in a statement. Additional observations should also reveal the shape of MK2's orbit around Makemake. If the orbit is tightly circular, the moon was probably created by a long ago giant impact, just like the 5 satellites in the Pluto system were, researchers said. A looping elliptical orbit, on the other hand, would suggest that MK2 was once a free-flying Kuiper Belt object that Makemake captured. What's curious about this is that given its size, you wouldn't expect a dwarf planet to have a moon, yet many of them do, which again flies in the face of the classification of what it means to be a planet, because there are ones that don't have moons, and yet are still called planets, and thus the debate continues over what it truly means to be a planet and whether the IAU are right to label something as not a planet when it shares so many characteristics with other planets. Number 2. Formation. Not unlike many other objects in the Kuiper Belt, Makemake is believed to have been made about 4.5 billion years ago when the formation of our solar system occurred. The only question mark in this is that when you look at the dwarf planet and you look at the others like it, you see a lot of differences as well as similarities. And it raises a lot of questions as to how some of these dwarf planets were formed one way while others weren't, especially when you compare them to the thousands of other objects that are in the belt that aren't their size. Only future observation will lead us to more answers. Number 1. Will we ever reach Makemake? Obviously, just about every astronomer in the world would like to go and reach every object that is out there in the solar system, so that they can study it up close. But being as this particular dwarf planet is just beyond Neptune, our options of reaching it are slim at present. Even if we were to go and launch a satellite to go and study it and the other dwarf planets, it would take years to reach it. That's not to say it won't happen, but for now, scientists and astronomers will just have to make do with the technology we have and hope that they can learn more about it from Earth. From its distance from the Sun to how it helped change the definition of a planet and more. Join me as I show you Eris, facts and history. Number 8. What is Eris? Depending on your familiarity with our solar system, you may or may not know about Eris, and for good reason, based on its location and how it relates to other planets and celestial objects in the system. In short, Eris is one of the largest known dwarf planets in our solar system. For those who don't know, a dwarf planet is one that has the size and shape of a planet, but fails to meet certain technical qualifications to be considered a full planet. Eris is about the same size as Pluto, but it is 3 times farther from the Sun, making it something on the very edges of our solar system. In fact, outside of some comets that have been discovered and a unique object from 2018, the two are the most distant known objects in our solar system. Eris first appeared to be larger than Pluto. This triggered a debate in the scientific community that led to the International Astronomical Union's decision in 2006 to clarify the definition of a planet. Pluto, Eris, and other similar objects are now classified as dwarf planets. Originally designated 2003 UB313 and nicknamed for the television warrior Xena by its discovery team, Eris is named for the ancient Greek goddess of discord and strife. The name fits since it remains at the center of a scientific debate about the definition of a planet. Number 7. The discovery of Eris. Given all we just told you, the discovery of this dwarf planet is really significant. Eris was discovered by the team of Mike Brown, Chad Trujillo, and David Rabinowitz on January 5, 2005, from images taken in October of 2003. The discovery was announced in July of 2005, the same day as Makemake, and 2 days after Haumea, 2 other dwarf planets, due in part to events that would later lead to controversy about Haumea. The search team had been systematically scanning for large outer solar system bodies for several years, and had been involved in the discovery of several other large TNOs, including 50000 Quaoar, 90482 Orcus, and 90377 Sedna. The reason that Eris wasn't discovered right away via the images in 2003 was very simple. Eris was moving so slowly that scientists weren't able to detect it. The team at the Palomar Observatory had automatic image searching software that excluded all objects moving at less than 1.5 arc-seconds per hour to reduce the number of false positives returned. When Sedna was discovered in 2003, it was moving at 1.75 arc-seconds per hour. And in light of that, the team reanalyzed their old data with a lower limit on the angular motion, sorting through the previously excluded images by eye. In January of 2005, the reanalysis revealed Eris's slow motion against the background stars, thus leading to its true discovery. After that, the team dedicated itself to learning more about the soon-to-be-named dwarf planet, mainly learning what kind of orbit it had, and eventually learning the discovery that it had a moon within its orbit. Number 6. The Xena name. I'm sure some of you out there were a bit curious as to why a scientific team would nickname a planet Xena after the legendary TV show featuring Lucy Lawless. Granted, that's not the name the dwarf planet has now, but the story behind this nickname is honestly rather unique to our solar system. Due to the uncertainty over whether the object would be classified as a planet or a minor planet, because different nomenclature procedures apply to these different classes of objects, which would lead to the demoting of Pluto not after Eris's discovery and classification. The decision on what to name the object had to wait until after the August 24, 2006 IAU ruling. As a result, for a time the object became known to the wider public as Xena. But why that one? Xena was an informal name used internally by the Discovery team. It was inspired by the title character of the television series Xena, Warrior Princess. The Discovery team had reportedly saved the nickname Xena for the first body they discovered that was larger than Pluto. According to Mike Brown, who was part of the team that discovered the dwarf planet, we chose it since it started with an X, Planet X. It sounds mythological. Okay, so it's TV mythology, but Pluto is named after a cartoon, right? And this part is actually true. We've been working to get more female deities out there. Example, Sedna. Also at the time, the TV show was still on TV, which shows you how long we've been searching. He noted that the name was honestly a bit of a joke to have fun with, because the team figured that a true name for the object would come relatively quickly, but it didn't. The process was delayed because of the classification issue, and thus Xena stuck for a long time. As for how that name got stuck with the public at large, you can blame the press for that. One reporter, Ken Chang, called me up from the New York Times, who happened to have been a friend of mine from college, and I was a little less guarded with him than I am with the normal press. He asked me, "What's the name you guys proposed?" And I said, "Well, I'm not going to tell." And he said, "Well, what do you guys call it when you're just talking amongst yourselves?" As far as I remember, this was the only time I told anybody this in the press, and then it got everywhere, which I only sort of felt bad about. I kind of like the name. While obviously Eris would take hold as the true name, the notion that Xena as the dwarf planet's title held on for a while is a pretty special thing, and you can bet that the show and its stars were happy to have made an impact of such a nature that they had a planet named after them, for a while anyway. Number 5. The classification debate. Eris is a trans-Neptunian dwarf planet, Plutoid. Its orbital characteristics more specifically categorize it as a scattered disk object, SDO, or a TNO that has been scattered from the Kuiper belt into more distant and unusual orbits following gravitational interactions with Neptune as the solar system was forming. Although its high orbital inclination is unusual among the known SDOs, theoretical models suggest that objects that were originally near the inner edge of the Kuiper belt were scattered into orbits with higher inclinations than objects from the outer belt. Because it was initially thought to be larger than Pluto, Pluto is a bit larger in volume, it would be later discovered, It was described as the 10th planet by NASA and in media reports of its discovery. In response to the uncertainty over its status, and because of ongoing debate over whether Pluto should be classified as a planet, the IAU delegated a group of astronomers to develop a sufficiently precise definition of the term planet to decide the issue. The irony of this is manifold, not the least of which is that for many decades the definition of a planet was very loose, which was why Pluto was named and held as a planet for so long. There are also those who say that the new classification system isn't true, but is just an arbitrary decision made by some and not by all. This new system was announced as the IAU's definition of a planet in the solar system, adopted on August 24, 2006. At this time, both Eris and Pluto were classified as dwarf planets, a category distinct from the new definition of planet. Mike Brown, who helped discover Eris as we noted earlier, has since stated his approval of this classification. The IAU subsequently added it to its minor planet catalog. There are some who choose to ignore this classification based solely on how it's not fair to Pluto, and to those who taught astronomy and declared it as a planet. As such, some refuse to label it as a dwarf planet. It's very curious how a simple discovery can upend everything you thought you knew about something. Number 4. Orbit. Eris has an orbital period of 559 years. Its maximum possible distance from the Sun, aphelion, is 97.65 AU, and its closest perihelion is 37.91 AU. It came to perihelion between 1698 and 1699, to aphelion around 1977, and will return to perihelion around 2256 to 2258. Unlike the 8 planets whose orbits all lie roughly in the same plane as Earth's, Eris's orbit is highly inclined. It is tilted at an angle of about 44 degrees to the ecliptic. When discovered, Eris and its moon were the most distant known objects in the solar system, apart from long-period comets and space probes. It retained this distinction until the discovery of 2018 VG-18 in 2018. Eris's orbit is highly eccentric and brings Eris to within 37.9 AU of the Sun, a typical perihelion for scattered objects. This is within the orbit of Pluto, but still safe from direct interaction with Neptune, approximately 37 AU. Pluto, on the other hand, like other Plutinos, follow a less inclined and less eccentric orbit, and protected by orbital resonance can cross Neptune's orbit. In about 800 years, Eris will be closer to the Sun than Pluto for some time. Because of the high inclination of its orbit, Eris passes through only a few constellations of the traditional zodiac. It is now in the constellation Ceres. It was in Sculptor from 1876 until 1929, and Phoenix from roughly 1840 until 1875. In 2036, it will enter Pisces and stay there until 2065, when it will enter Eris. It will then move into the northern sky, entering Perseus in 2128, and Cameloparadilis, where it will reach its northernmost declination in 2173. Number 3. Formation and structure. Dwarf planet Eris is a member of a group of objects that orbit in a disk-like zone beyond the orbit of Neptune called the Kuiper Belt. This distant realm is populated with thousands of miniature icy worlds, which formed early in the history of our solar system, about 4.5 billion years ago. These icy rocky bodies are called Kuiper Belt objects, trans-Neptunian objects, or Plutoids. The irony, though, is that, as we mentioned earlier, Eris is way out there in the solar system. It's one of the farthest objects from the Sun, and unlike many in the Kuiper Belt, it's not surrounded by a lot of other objects, which is part of the reason why it took so long to discover. So the question is, if it formed very much like the other objects in the belt, how was it formed so far away? We know that the Sun's gravity has an enormous range, as proven by the dwarf planet's orbit, for if it wasn't in the range of the gravity, it wouldn't be orbiting the star. But how was it able to make an object of that size that's so far away? Which brings us to the mystery of its structure. Because of its enormous distance from us, we honestly don't know much about what makes the dwarf planet tick in terms of its rock structure, its elements that make it up, etc. Now, yes, we can guess some things based on pictures, Eris most likely has a rocky surface similar to Pluto, which would add up given their distance from the Sun and the particles and elements that likely formed them. Also, scientists think surface temperatures vary from about minus 359 degrees Fahrenheit, minus 217 degrees Celsius, to minus 405 degrees Fahrenheit, minus 243 degrees Celsius, which obviously would make it a very cold and frozen world, again just like Pluto. But the inner workings of the planet? We have little to no clue as to how that is, and unless we get a craft to where it is, that's not likely to change. Could we get something there one day? Absolutely, but the question is one of when and how long it'll take to not just get there, but get meaningful data from it. Number 2. Its moon. Eris is a very small moon called Haumea. Haumea has a nearly circular orbit lasting about 16 days. This moon is named after Eris's daughter, the demon goddess of lawlessness. A very curious pairing of names, and yet somewhat accurate given what these celestial objects have done in terms of their impact on the solar system. Haumea and other small moons around planets and dwarf planets allow astronomers to calculate the mass of the parent body. Haumea played a role in determining how comparable Pluto and Eris are to each other. Number 1. Atmosphere. The dwarf planet is often so far from the Sun that its atmosphere collapses and freezes, falling to the surface as snow. As it gets closest to the Sun in its faraway orbit, the atmosphere thaws, which is something you wouldn't expect from a planet or dwarf planet at all, further showing how location in the solar system is infinitely important. If you're curious about the magnetosphere, there is no evidence that it has one, but there also isn't any evidence that it doesn't have one. This is another case where its distance harms how much we can learn about it as a whole.